All right, so we're going to use that periodic table with oxidation numbers a lot in this unit. So I just introduced you to the periodic table with oxidation numbers that you have in your test references. Okay? We're going to be using that quite a bit in this unit. Okay? We're also going to be using another reference that's in your handout, in your test references, and that's the common ions list. So look at those right now, get out your test references, and take a look at the common ions list and the periodic table with oxidation numbers. Okay? You need to be aware of both of those, and we need to learn to use them. Okay? All right, so there are major classes of compounds that all have different naming systems. Okay? Major classes of compounds that have different naming systems. And we've already looked at two of those, a little bit anyway. We've looked at ionic compounds. Okay? And we've looked at covalent compounds. So the way you name ionic compounds is different from the way you name covalent compounds. Okay? Sometimes they sound the same, but there are some differences. Okay? Now, in covalent compounds, there are two subclasses that each have their separate ways of naming. Okay? We have non-organic and we have organic compounds. Okay? Non-organic and organic. And these two ways of naming covalent compounds are different. All right? And then we have acids. Okay? Now, acids are not quite ionic compounds and not quite covalent compounds. Sometimes they're one, sometimes they're the other. Okay? So they have a different naming system. But these particular acids are the non-organic acids. Non-organic acids. Okay? There are organic acids get named in the organic compounds system. The non-organic acids get named using something similar to the ionic compound system. But they're not really ionic and not really covalent. Sometimes they're one, sometimes they're the other. Okay? All right. We talked about the term binary a moment ago, and I want to start with a simple set of binary ionic compounds. Binary ionic compounds. So we put together this compound a little while ago using this concept we call Lewis dots or electron dot formulas. And we found that we had potassium put together with nitrogen. Potassium's a metal, nitrogen a nonmetal. If I put together a metal and a nonmetal, then I must have, or most likely going to have, an ionic compound. Okay, so we're going to use the ionic compound system. Okay. All right. The way we're going to name these simple binary compounds, and this is a binary compound because it only has two elements. Now notice it has 4 atoms. But when we use the term binary to refer to a compound, we're not talking about the number of atoms, we're talking about the number of elements. And there are only 2 elements. the element potassium and the element nitrogen. 2 elements. That makes sense? Binary refers to the number of elements. Okay? All right. So let's name this then according to this system. This is pretty simple. Okay? We're going to name the first element, the metal element always comes first. We name the first element exactly as the name appears in the periodic table. Okay? First element always the metal. Is named just as it appears on the periodic table. All right. The second element in a binary ionic compound. So it has to be a metal and a nonmetal here. The second element, always the nonmetal, is named as it appears on the periodic table but the end of the name is changed to an IDE suffix. All right. So, naming this compound then, K3N, what are we going to call the first element there? What? Potassium. And what are we going to call the second element in this name? Nitrite. Okay? Nitridide, okay, that's fine, but it just sounds better, nitrite, okay? Potassium nitrite. Got that? All right, let's see if we can do something else here. How about we do okay, name this compound then. You practice. You name this compound. Not when you're naming ionic compounds, you don't.
What?
What?
What we're doing.
We're naming this compound right here.
No, this is unit 4.
Oh, we're in unit 4, yes. Yep, we're in unit 4 right now. Okay. Okay. Scandium chloride. Notice I'm not capitalizing. Okay. Element names are not proper nouns, so you don't capitalize them. Okay. Element names are not proper nouns. You don't capitalize them unless they're the first name in a sentence or something. Okay. Now,
They're not proper?
They're not proper nouns. Remember, proper nouns are like your name or a city name or a state name, right?
Mm-hmm.
Proper nouns get the first letter capitalized. Okay? All right, now we said the first element's always named just as it appears in the periodic table. But there's an asterisk there. And the reason there's an asterisk there is metal elements with more than one oxidation number must have a Roman numeral. To show the appropriate charge. Okay, everybody got that? Right next to scandium then is titanium. If you look on this periodic table that I'm showing you, titanium has how many different charges? How many? 3. Okay, I thought I heard you say 2. All right. So it has 3 different charges. So if I'm going to be writing a formula then for titanium, let's see, let's use this formula right here. I need to figure out what the charge is on this titanium to name it properly. Okay? So we go over here to bromine, and we see that bromine has 4 different possible charges. Titanium has 3 charges, but they're all similar in one way. What's the similarity in all those charges? They're all plus charges. So in order to get for this compound to be neutral, right, we have to use the negative charge on the bromine. There's no other way to get it to be neutral, right? Okay. So we need to have bromine with a 1 negative charge. And we know we have 4 of those bromines here, because that 4 right there tells us that. We have titanium with a charge that we don't know right now. Okay, I don't know what its charge is going to be yet. Okay, but I know I just have 1 of them. Okay, well down here when we did the math earlier, we wanted the whole thing to work out to be 0. Remember that? We've got 4 times 1 negative, and we have some number here multiplied by the 1 we don't know. Well, what number has to go there to make that thing equal 0? 4. So the only charge that's going to work on this titanium is that 4 plus that's right there. Okay? So we had to figure out what that charge number is. Now that we know the charge number, we can write the name. So the name of this compound then is titanium 4. Roman numeral 4, bromide.